Hello, today we are starting a brand new chapter, chapter 6. It is all about square roots and radical functions, and the first section, 6.1, is titled Roots and Radical Expressions, and the learning target today is to evaluate the nth root of any expression. This could be a number, it could be an algebraic expression with some variables and other exponents, but we're going to look at a few different ones today. The first thing I want to get to is that if you have any number raised to the power n is equal to any other number, then A, that number, is considered an nth root of B. And this may seem incredibly confusing now, but when I get through some examples of numbers that actually make sense, then it will be a bit more realistic. But this theorem, this equation, only works if A and B are both real numbers. So it doesn't work if we have an I, since that is not a real number, that's a complex number, and other rational expressions. Kind of the layout of what a radical expression may look like is if you have some number right here that is called the radicand, and that is underneath your radical sign, or I may call it the root sign, and the number on the outside of the root is your index, which is the degree of the root. If you do not see any number outside of the radical, assume it is always a 2. If there is no n listed in the problem in the radical, then that means that this number is a 2 or a square root. Okay, so the first problem I want to go over with you guys is, what is the cubed root of 8? Now the very easiest way to set this up is to just write the number 8 is equal to x raised to the power of 3, since we are looking at the cube. But since we are looking to get x by itself, the one way that we get rid of a cube raised to the power is to take the cubed root of it. So then these cube and the cubed root cancel out. We're left with x is equal to the cubed root of 8. And if you have a calculator, a way you can solve this is to take your number 8 and raise it to the power of 1 over 3. The denominator of the fraction is always going to be the number that is outside of the radical. And since we don't have any exponents on the inside of the radical, this number is going to be 1. So 8 raised to the power of 1/3 is the exact same thing as the cubed root of 8. Hit enter and you will see that x is equal to 2. So 2 is a cubed root of 8, or 2 cubed is equal to 8. Okay, the next problem is, what is the fifth root of 32? We set this up the exact same way we did last time. Take 32 is equal to x raised to the power of 5. But the way we can get rid of this 5 as an exponent is to take the fifth root of both sides. The fifth root and the fifth cancel out, so we're left with the fifth root of 32 is equal to x. And if we plug that into our calculator, we take 32 raised to the power of 1 over 5, and we will get the exact same number of 2. So this tells us that 2 raised to the power of 5 is equal to 32. That is the fifth root of 32. Okay, a few more other ones I want to go over with is taking the root of any negative number, and this can simply be done by just taking our calculators, taking the quantity of negative 81 and raising it to the power of 1 over 4, and this will give us a non-real answer by using the calculator. Okay? Taking the fourth root of a negative number will give us a non-real answer. Now taking a look at the same thing, but this time with a cubed root of a negative number, negative 27 raised, let me start over, negative 27 raised to the power of 1 over 3. This will give us an answer of negative 3. So why does a negative number underneath our radical sign give us a non-real answer for 4, but if it's 3, it gives us an actual answer. Well, this happens for two different reasons. If n is odd on the outside of our radical, then there is one real answer. In this example up here, our 3 is an odd number, so we have one real answer of a -3. If the number on the outside of the radical sign is even, and the number on the inside is positive, I meant this to say a, and a is positive, then we will have two real answers. So since in this example up here, n is even, but our number on the inside of the radical is not positive, then we do not have two real answers. We go down to here where we have n is even, number 4, and a is negative, -81. That means there are no real answers. So whenever you're looking at radicals, you have three different options. You will have one real answer, two real answers, or no real answers. Depending on what the numbers on the outside and inside are, they will tell you whether you have one real answer, like this example up here, n is odd, one real answer. No matter what this is positive or negative, you will always have one real answer. And if n is even on the outside, it depends on whether this is positive or negative, and you may have two real answers or no real answers. Let's take a look at examples with some algebraic expressions. This one we have 16x to the 8th, and this is a radical sign on the outside. Since this has no number, I'm going to understand that this is a 2 on the outside. If you never see a number, it will always be a 2. Okay, the first thing I like to do is to split it up with numbers in one radical and exponents on the other. So I have the square root of 16 times the square root of x to the 8th. Since there is a times between them, I can factor out the two different ones and get multiply between each of my factors. The square root of 16 is equal to 4, and the square root of x to the 8th is the exact same thing as x to the 8th raised to the 1/2 power. Now we learned back in Algebra 2 that whenever you take an exponent raised to another exponent, you multiply them together. So 8 times 1/2 is equal to 8/2, which 8 divided by 2 is equal to 4. So instead of the exponent being 8 raised to the 1/2, it's the same thing as x raised to the 4. So our final answer is 4x raised to the 4 power. Splitting up the numbers and the variables on each side and simplifying them down separately. The next one is the cubed root of a to the 6th times b to the 9. And again, I'm going to separate these two with my a as one radical and b as the other. We have a to the 6th the cube root times the cubed root of b to the 9. And since this number on the outside of the radical is a 3, I could rewrite this expression as a raised to the 6th divided by 3. Changing it from radical form to exponential form. If you need to review a little bit from AG2, this is converting from radical form to exponential form, and there's other videos that you can find that explain this a bit better. So b to the 9th over 3, since my 3 is on the outside of the exponent. Now these fractions, 6 over 3 reduce to a 2, 6 divided by 3 is 2, and b to the 9 over 3 reduces to b cubed. And since I cannot combine these, they are not like terms, I will leave this as my final answer. Okay, so this is the end of the video, and before we get started on any of the work in class, I will talk a bit about the learning target goals and some of the question answer process that we will be getting through a bit more regularly. Okay, thank you.